All right, everyone. Hopefully you were able to grab a snack or some coffee. Please make it back to your seats. We have one more talk today before we get into our question and answer session and then our networking hour. So again, my name's Donovan. I'm a developer programs engineer on the Ad Manager API, and today I'm going to be talking about some API use cases. These are things that we've seen either a lot of publishers using or a few publishers use, and it's a very novel or unique idea. So already today we've seen so many great tips and advice for using the API and using Google Publisher tags, some very specific things. But this talk is really more about looking at things from a high level. What I'm hoping from this talk is that you're either doing something similar to a use case, but you learn a best practice around it, or you've never even considered doing something like one of our use cases, and it helps spark your imagination for ways you can adapt it to your own business. So I'll be going over 4 use cases. First, we have maintaining a data warehouse, which is a very common use case. Then I'll go into dynamic key value reporting, which is something you can do with the Ad Manager API. Then we'll look at a use case I've called Premium Ad Unit Package. And finally, we'll look at ContentAware Targeting. So first, let's go into maintaining a data warehouse. So like I said, this is a very common use case, but usually what this involves is pulling a lot of data from Ad Manager to your own on-premise servers or a cloud server that you maintain. And so whenever you're dealing with a lot of data, it's important to get the details right. So as a scenario, suppose you run your analytics software on your network's data for up-to-date insights. And we have a requirement that the Ad Manager data must exist on the same system so that the analytics software can interface with it. Usually when we talk about data warehouses, we're talking about 2 things. People are either trying to store a copy of their network entities. This will be line items, orders, et cetera. And then the other really big use case is reporting data. So we'll look at both of these. Both of these use cases basically have the same structure. You are typically running some sort of scheduled task, and then we branch off for the 2 types of data that you might be fetching. And then at the end, you're still, in both cases, putting them in some kind of database. So first, we'll look at network entities. So first, we want to fetch our line items, and this would do it if you just define an empty statement using a statement builder. Here we're using our Python client library utilities. The problem is this would fetch every line item every time, and if you're fetching this on a regular basis, there are better ways to do it. So one option is to fetch by last modified date time. So if we get the last time that the database was updated, and then we only update any line items that have been updated since then we can pretty reliably keep our database up to date. But in the meantime, we're making much smaller API requests. There is a caveat with this, though, that you should be aware of. If you depend on system changes, those do not update last modified date time. So if you have a generated field or some system field, last modified date time will not reflect that that field was updated. So you have to consider for your own use case, if you are sensitive or you need to store those generated fields and you need them to be updated, then maybe this is not the approach to take. Still, though, there are options for how to decrease the number of line items you're fetching. Something as simple as adding a where clause that excludes canceled line items or inactive line items can be another really good way than just naively fetching all of your line items every time. And so now we'll go over to reporting data, where there's a little bit more to say. So with reporting, right, you don't necessarily want just one number that represents your traffic. You want it broken down into useful bits to you. So you want enough granularity so that you can pull insights out of your data. But that comes with an asterisk because adding dimensions grows the number of rows exponentially. And I'm sure people have run into this where you're trying to run a report, but it does not succeed because there's too many rows. So let's just consider a report where we're using all of these 4 dimensions, and we have 30 days of reporting data. There's 200 line items, 100 cities, and 5,000 key value pairs. Key value pairs are permutations of all of your key values that you report on, so it actually is possible to get very high numbers there. If we tried to run this report, and if there was data for every possible row, this would equal 3 billion rows, billion with a B, so this would not run. Our system would not be able to support a report of this size. So the question is, how do we bring it down to something that we can maintain without losing the data that we've decided we need? The most straightforward way to do this is to break it up by day. If we're doing a 30-day time range, it's pretty simple just to request reports for 1 day and do that 30 times. And then you've still got all the same data. You can concatenate it or store it in the same database if you want. But now we've reduced our number of rows by a factor of 30. So we're down to 100 million rows, which is better, but it's still not where we need to be. So what else is there to do? In our reference documentation for report service, we have enumerations for all of the dimensions that the report service supports. And if you check the entry for line item ID, you'll see that it can be used for filtering by line item ID. So if we have a report that uses the line item dimension, or the line item ID dimension in this case, we can actually filter by line item ID as well, run a different report for each day and for each line item, still getting all of the city and the key value data that we need. And we've brought this report down to 500,000 rows. Which, according to our internal statistics, this would succeed in about the 99th percentile. So the code to do this is very simple. You just want to run a separate report for each of your line items, and graying out the sort of boilerplate, non-interesting bits. There's 3 main lines to focus on. First is the first line, where we're actually looping through a list of all of the line item IDs that we're interested in. And then again, it's a matter of defining a where clause on the statement for this report, and we're going to limit it to a single ID per report query. And then we use the third line in bold here is just a way that our client libraries bind the variable. So this is, again, something that you can do not only with line item ID, but other dimensions that support filtering as well. So another consideration when pulling in reporting data is that over time, you're building up a lot of data. And it's important that your data represents what you expect, because if you realize way down the road that you were capturing something that you don't need or isn't as valuable to you, it can be really expensive to go back and fix that after the fact. So I have 3 points to keep in mind. All of these points come from our Help Center documentation, so I've linked to the corresponding article here, in each case, actually. So the first is just to understand what metrics you're pulling. So if you're pulling columns for impressions, it's important that you know the difference between downloaded impressions versus viewable impressions, and whether what the ones that you're recording are the ones that are valuable for you to make decisions. So you can read more on the Help Center article, Ad Manager Report Metrics. The second thing to consider deals with assumptions about your reporting data. And so it's important not to double count, which is possible in a few circumstances. So one of these circumstances is with key value reporting, which I'll get to more in my next use case. But the point here is that an impression can match on multiple key value rows. So if you are making the assumption that your report, if you sum for a particular day, if you sum all of the impressions for that day and you expect to get the total number of impressions, that might not be the case if your report is subject to double counting. So there's a few other scenarios where this can happen too, so you can check the Help Center article about avoiding double counting. And then finally, if you're storing this data for a long time, you want to make sure the data that you have is representative of the data that is in Ad Manager. And there are some things that can cause the reporting data to fluctuate. We have things like invalid traffic detection, which looks for things like spam and fraud, where we try to remove any fraudulent data so that you have the best picture of your traffic. So reporting data typically is available after 4 hours, but then it's still subject to these adjustments. So if you wait until 4 a.m. Pacific time, it's California Pacific time, then the data for the previous month is frozen. So again, it's typical that these changes are not very large, but if you're sensitive to very specific changes, then you might want to double check your data. So that's everything that I have for maintaining a data warehouse. It is the most common use case, so I spent the most time on that one. But we have 3 more to get to. So the next one, switching gears, is about dynamic key value reporting. So earlier, we heard the term key value targeting, and I'm sure most of you know what key value targeting is, but if not, it's a way to specify custom keys and then custom values belonging to those keys that you can target with. And in the API, the corresponding objects are custom targeting keys and custom targeting values. So this use case explores how we can get a little more out of our reporting by using the API. So the scenario here is that you have a content management system for generating content. And that content can be tagged. And you need to be able to add those tags to Ad Manager and report on them automatically. So it's important to talk about the 2 different types of key values. So there's predefined, and then there's freeform. So predefined, like it sounds, you specify all of the values up front. But freeform is more dynamic in that it lets you to define values on the fly. So if we're talking about articles in a CMS here, some predefined key values might be things like top story, feature, editorial, biographic. These could be all things that you tag an article with. And these things, they don't change that much over time because they're more of a structural concept. But then the content might have article tags like Taylor Swift, the Google Pixel, streaming, and these things are much more likely to change over time. So using freeform keys values in this case makes more sense. So you might be thinking, well, why don't I just always use freeform? Because it's more flexible. And while the first row demonstrates that the dynamic values are supported in freeform key values, the drawback is that they're not available for custom dimension reporting. So you can actually run reports and see how your different key values are performing, but not with freeform. So this use case is architected in 2 tracks. The first is triggered by the CMS that you have generating a new tag, and then that will kick off an Ad Manager script to create the key value in Ad Manager. And then once it's created, you can separately have some sort of regular task that's generating a report, and I'll show you how to generate a report in API that leverages those custom values. So first we'll look at the creation of the key value. So the very first thing is we are defining a custom targeting value object. There are a few required fields on this. There's the custom targeting key ID, right? Values have to belong to a key. So that tag key ID is just the one that we're using to track all of our content tags, and it's passed into this function. The second field that we define is the display name. This is the tag name that came from your CMS. Someone entered a new tag, and that name is what we want to create here. I've set that on the display name and the name field. One thing to note about the name field is that it could be visible to end users. So if you need to obfuscate it, you should. And then finally, we're making this match type exact because we want to match exactly on those tags. So this would be fine for creating it, but remember there was a second part to our requirement that we want to be able to report on them as well. So we actually need one more field, and we need to give it a reportable type of custom dimension. And once we've done that, that will allow us to run the report, which I'll get to next. And you should keep in mind that there are system limits with the number of custom dimension key values that you can have, so you should check that. There's a link in the resources to that Help Center article. So now let's look at how you actually run the report. So this report job is pretty standard, very similar to any other report job. The only key difference to point out is that the dimension that we're specifying is custom dimension. And here it's the only dimension that I'm specifying, but just like other dimensions, you can mix them to break down your data further. When you have custom dimensions in the dimensions list, however, you do need to specify one additional field on the report query, and that's custom dimension key IDs. And this is going to be a list of all of the custom targeting keys that you want to be included in your report. So we're going to reuse the tag key ID from the previous slide, and now we've satisfied both parts of our requirements for this use case. So while the previous two use cases were on the more common side, you've probably done something like it or very similar. The next two are a bit rarer in my experience. Let's see what Premium Ad Unit Packages is about. So the scenario here is that your site consists of many pages, each of which can go up and down in popularity from day to day. Sounds like a lot of sites. And the requirement here is that you want to give advertisers a way to target the currently highest performing pages at some kind of premium because they are higher performing. So this also has two tracks. First, we are going to set up a scheduled task, and then the scheduled task is going to make a query to Google Analytics to get your page data. And then with that, we will update a placement, which if you're not familiar with a placement in Ad Manager, it's just a collection of ad units. And then after that, we'll show how to create a proposal line item and then target that placement through the placement ID. So first, let's look at how we'll actually update the placement. So first, I've just defined a function to get the best performing pages. The reason I'm not including the code here is because there are multiple APIs with Google Analytics that you can use. There's a real-time reporting API to get more up-to-date data. So depending on which one you use is dependent on your use case. But so let's just assume that we have the list of high-performing ad units. Let's see on the Ad Manager side what needs to be done. So first, we have some placement created in our network that's going to represent the collection of high-performing ad units. And that's the one that we need to keep updated. So we're going to, again, I've abstracted the Ad Manager logic here, but there's an exact example in all of our client libraries that will show you how to get a placement, which I've also included in the resources slide. So we're going to get the placement itself. And then the interesting part is that we want to set the targeted ad unit IDs of the placement. So really all we need to do is loop through the ad units that we got earlier, extract the ID field, and then set that to the targeted ad unit IDs. And then finally, we need to update the placement back in Ad Manager, which again, the example is in the resources slide. So conceptually, that's how we update the placement. Now we just need to look at how we would make use of that placement through inventory targeting. So say we were creating a proposal line item. There are, again, some required fields. We have name, proposal ID, et cetera. But here, the interesting part is the targeting. So inventory targeting is a required field on targeting, and you might be more familiar with setting ad units or excluding ad units from your targeting, but you can also target placement IDs. So in this case, we would just want to pass in a list that consists of one ID, which is the high-performing placement ID from the previous slide. So it's pretty straightforward, honestly, this use case, but it's interesting because it creates a potential for if you have a sales team that's looking for new ways to package your inventory, this opens up that possibility. So the last thing that I'd like to look at today is content-aware targeting. So this is actually going to look at content around where you have an ad slot and make it relevant to the content. So the scenario here is that you say you own a social site where users can upload and share photos. This example will be looking at images, but you can generalize it to other types of content as well. And our requirement is we want to show ads that are relevant to nearby user images. So this use case, again, is broken into 2 tracks. It looks a little complicated, but I've really broken down the steps very fine-grained. So it's not as bad, and we'll step through many of them. So first, on the left-hand side, a user has uploaded an image. So we need to process that image. We need to extract the metadata that we'll be using. And then we're going to pass that metadata in and cross-reference it with our custom targeting. And then we're going to store that metadata in a database to use on the right-hand side. So then a user loads the site. What we want to do is we want to fetch that image and the metadata. And then we're going to use that metadata to set custom targeting on an ad request. So first, we have to look at how are we going to get the metadata in the first place. So say we have this image that a user has uploaded. There is a cloud API called the Cloud Vision API that makes getting data out of this image incredibly easy. So we'll see in code in a second, but conceptually, there's a function call on this API where you can extract a list of labels and a confidence score associated with each label. So here I've done that for this image. They're sorted by confidence score, so the most confident labels are at the top. We have bicycle, which is pretty prominently displayed in the image. Street fashion, which might be relevant to an ad. And then things like vehicle, transport. This image API isn't fine-tuned for our purposes, so it's trying to find everything it can. So it also pulls out leg, because there is a leg in the image. But this list is very comprehensive of everything that it can find in the image. So the code here is actually very straightforward. First, we just need to import the Vision API. And then we're going to define a 4-line function to extract the metadata from an image that we pass in. So the first thing you need to do is you need to initialize an image annotator client. All you need to do this are credentials that you would set up in the developer console in Google Cloud Project. Very similar to how you would set up a service account for Ad Manager. So once you have that client, you can take your image content, which in this case I'm using the functionality of the API that uses like a base64 encoded image. You can also pass in a URL to an image, but from that we generate an image object. And then getting the labels is one function call. You just call label detection on the image. So now we have the labels and we return them from our function. So now that we have that metadata, again, we have the full list and we need to trim it down to what's useful to us. So we want to take this and get rid of anything that isn't relevant and we can't use for custom targeting. So the first thing that we need to do is we need to actually get the categories that we have available to us. So like we've done in a previous example, we're going to assume that on our Ad Manager network, we have a custom targeting key that represents all the categories that we have available to us. And then I'm calling a function to get all of the custom targeting values. And then I loop through and extract the display name, because that's going to be the piece that we want to match on. And we store that into a categories variable. Then we need to use the function that we defined on the last slide, extract the metadata from the image, and pull out the name from all of those labels. Here, if you wanted to set some sort of threshold, if you only want something with a certain confidence score, this is where you would set that. But for us, all we want to do is we want to cross-reference with the categories that we have available to us. So in Python, this is very easy. We just loop through each label. And if the label is in categories, then we add it to a matching labels list. And all that remains is to store that list in our database along with our image. So now we have the image tied to its labels, and we can use that next. So when the user loads a slide, we need to fetch the image and the metadata, and then we're going to see how to set that custom targeting. So we've seen examples today of using GPT. In this case, we're using the Google tag library to define an ad slot. We have to pass in ad unit size, and then the ID of the ad slot where the ad will go. And then we're just going to fetch the categories from the database if it exists, and if it has any values in it. On the ad slat, we will call set targeting. Our key, remember, is category, and then the list that we want to target is the full categories list. And it's really as simple as that. So in this talk, I really just wanted to, again, go through how we've seen people using the API, maybe spark some new ideas in yourself. If you have interesting ways that you're using the API, I'd love to hear about it later. And while they were all very distinct use cases, they did have some common through lines. To echo what Alex said in the keynote, the API is really meant to save you time and automate manual workflows. Another great thing about the API is you can actually support other teams within your business, whether you have a data analytics team and you're maintaining a data warehouse for them, or you have a sales team and they need new ways to package inventory. And then it really all comes down to finding opportunities, adapting these use cases to your own business, and using the API. So like I promised, I have a very dense resources slide because I referred to it a lot. OK, yeah. Oh, thank you.